everyone, this is Kalpana here. In this video, we're going to see a problem from partial differential equation. So let's get going. Problem: form partial differential equation from z equal to f of x plus y into phi of x minus y by eliminating the arbitrary functions f and phi. We are given a relation. We are asked to form a partial differential equation from it by eliminating f and phi. Let's see. Given z equal to f of x plus y into phi of x minus y, right? Consider as equation number 1. Now let's partially differentiate it with respect to x. Partially differentiating 1 with respect to x. Just apply dou by dou x on both sides of 1. This gives us dou z by dou x equal to, here you're having f into phi. You're going to apply uv whole prime formula, that is u prime v plus v prime u. Partial, so let's write f of x plus y into partial derivative of phi of x minus y plus phi of x minus y into partial derivative of f of x plus y. Since we are partially differentiating with respect to y, so we'll treat y as constant, and we can replace dou z by dou x by the notation p. This gives us p equal to f of x plus y into partial derivative of phi of x minus y is phi dash of x minus y into its inner derivative dou by dou x of x minus y plus phi of x minus y into partial derivative of f of x plus y is f dash of x plus y into its inner derivative dou by dou x of x plus y. Right? This gives us p equal to f of x plus y into phi dash of x minus y into partial derivative of x with respect to x is 1 minus partial derivative of y with respect to x is 0 plus phi of x minus y into f dash of x plus y into partial derivative of x with respect to x is 1 plus partial derivative of y with respect to x is 0. Right. This gives us p equal to 1 minus 0, 1 into phi dash into f is f phi dash, that is f of x plus y into phi dash of x minus y. 1 plus 0, 1 into f dash is f dash into phi is phi f dash, that is phi of x minus y into f dash of x plus y. Consider as equation number 2. Okay, now let's partially differentiate 1 with respect to y. Now let's partially differentiate 1 with respect to y. Just apply dou by dou y on both sides of 1. This gives us dou z by dou y equal to, here we have two functions and we need to find partial derivative of product f and phi. So we'll apply uv whole prime formula here. We'll get f of x plus y into partial derivative of phi of x minus y plus phi of x minus y into partial derivative of f of x plus y. Since we know that dou z by dou y can be replaced by the notation q, just replace it by q, you'll get q equal to f of x plus y into partial derivative of phi of x minus y is phi dash of x minus y into its inner derivative, that is dou by dou y of x minus y plus phi of x minus y into partial derivative of f of x plus y is f dash of x plus y into dou by dou y of x plus y. This gives us q equal to f of x plus y into phi dash of x minus y into partial derivative of x with respect to y is 0 minus partial derivative of y with respect to y is 1 plus phi of x minus y into f dash of x plus y into partial derivative of x with respect to y is 0 plus partial derivative of y with respect to y is 1. This gives us q equal to 0 minus 1 minus 1 minus 1 into phi dash is minus phi dash minus phi dash into f is minus f phi dash. You'll get minus f of x plus y into phi dash of x minus y. Right. 0 plus 1 is 1. 1 into f dash is f dash. F dash into phi is phi f dash. So we'll get plus phi of x minus y into f dash of x plus y. Okay. Or you can write the same thing as, let's write the term involving plus sign first. So we'll get phi of x minus y into f dash of x plus y minus f of x plus y into phi dash of x minus y. Consider it as equation number 3. That is q equal to phi of x minus y into f dash of x plus y minus f of x plus y into phi dash of x minus y. Right. Let's now find equation involving r. We know that r is nothing but dou square z by dou x square. We can write this as dou by dou x of dou z by dou x. Since dou z by dou x is nothing but p, so we'll get dou p by dou x. Dou p by dou x is nothing but r. So now to find equation involving r, what we are going to do is we are going to use equation involving p and we'll partially differentiate it with respect to x so that we'll get equation involving r. So let's partially differentiate 2 with respect to x to find equation involving r. Partially differentiating 2 with respect to x. Here p is nothing but dou z by dou x. Okay, you can write dou z by dou x or you can write p. So now we are going to apply dou by dou x on both sides of 2. This gives us p is nothing but dou z by dou x, or you can just directly write dou p by dou x here. Okay, you can write like this or you can write dou p by dou x simply. Okay, equal to, here we are partially differentiating with respect to x, so we'll treat y as constant. Again you are going to apply u v whole prime formula because we are having two functions. So let's write it, f of x plus y into partial derivative of phi dash of x minus y plus phi dash of x minus y into partial derivative of f of x plus y plus phi of x minus y into partial derivative of f dash of x plus y plus f dash of x plus y into partial derivative of phi of x minus y. Right, this gives us dou square z by dou x square equal to f of x plus y into partial derivative of phi dash of x minus y is phi double dash of x minus y into inner derivative, that is dou by dou x of x minus y plus phi dash of x minus y into partial derivative of f of x plus y is f dash of x plus y into its inner derivative dou by dou x of x plus y, right, plus phi of x minus y into partial derivative of f dash of x plus y is f double dash of x plus y into its inner derivative dou by dou x of x plus y plus phi dash of x minus, here you're having f dash, right, f dash of x plus y into partial derivative of phi of x minus y is phi dash of x minus y into its inner derivative dou by dou x of x minus y, right. This gives us, since we know that dou square z by dou x square equal to r, we'll just replace this by r. We'll get r equal to f of x plus y into phi double dash of x minus y into partial derivative of x with respect to x is 1 minus partial derivative of y with respect to x is 0 plus phi dash of x minus y into f dash of x plus y into partial derivative of x with respect to x is 1 plus partial derivative of y with respect to x is 0 plus phi of x minus y into f double dash of x plus y into partial derivative of x with respect to x is 1 plus partial derivative of y with respect to x is 0 plus f dash of x plus y into phi dash of x minus y into partial derivative of x with respect to x is 1 minus partial derivative of y with respect to x is 0, right. This gives us r equal to 1 minus 0 1, 1 into phi double dash is phi double dash into f is f phi double dash, that is f of x plus y into phi double dash of x minus y, right, plus 1 plus 0 is 1, 1 into f dash is f dash into phi dash is phi dash f dash, so you'll get plus phi dash f dash, right, plus 1 plus 0 is 1, 1 into f double dash is f double dash into phi is phi f double dash, so I'll get phi of x minus y into f double dash of x plus y, right, plus 1 minus 0 is 1, 1 into phi dash is phi dash into f dash is f dash, we'll get f dash phi dash, so plus f dash phi dash, okay. Do you have any like terms here? F dash phi dash f dash, phi f double dash, f dash phi dash. You have one like term, right? So you can write this as r equal to f of x plus y into phi double dash of x minus y, phi dash f dash plus phi dash f dash gives 2 phi dash f dash. Okay, we are adding this 2, which gives us 2 phi dash f dash plus phi of x minus y into f double dash of x plus y. Consider as equation number 4, which involves r. Now we will find equation involving t. You know that t is nothing but dou square z by dou y square, or we can write this as dou by dou y of dou z by dou y. Since we know that dou z by dou y is q, this can be replaced by the notation q, since dou z by dou y equal to q. Right, you will get dou by dou y of q, which is nothing but dou q by dou y. Dou q by dou y is nothing but t. So now in order to find equation involving t, we will use equation involving q and we'll partially differentiate this equation with respect to y, so that we'll get equation involving t. Now what we are going to do is we'll just partially differentiate 3 with respect to y. Partially differentiating 3 with respect to y. Just apply dou by dou y on both sides of 3. Q is nothing but dou z by dou y, right? Is equal to, here we are partially differentiating with respect to y, so we'll treat x as constant, and here you're having f phi dash, phi f dash, f phi dash. We are going to apply the same formula again. Okay, so phi of x minus y into partial derivative of f dash of x plus y minus, plus, you have to apply u v whole prime is u v whole prime, okay, u into v prime plus v into u prime, dou by dou y of phi of x minus y minus f of x plus y into the partial derivative of phi dash of x minus y plus phi dash of x minus y into partial derivative of f of x plus y. You have to do carefully, okay, otherwise you may get mistakes. Right, this gives us dou square z by dou y square equal to phi of x minus y into partial derivative of f dash of x plus y is f double dash of x plus y into its inner derivative, that is dou by dou y of x plus y plus f dash of x plus y into partial derivative of phi of x minus y with respect to y is phi dash of x minus y into dou by dou y of x minus y, right, minus of, here you'll get one more bracket, okay, a minus of f of x plus y into partial derivative of phi dash of x minus y with respect to y is phi double dash of x minus y into inner derivative dou by dou y of x minus y plus phi dash of x minus y into partial derivative of f of x plus y with respect to y is f dash of x plus y into inner derivative dou by dou y of x plus y, right? Since dou square z by dou y square equal to t, we'll just replace it by t, we'll get t equal to phi dash, sorry it's phi, right, phi of x minus y into f double dash of x plus y into partial derivative of x with respect to y is 0 plus partial derivative of y with respect to y is 1 plus f dash of x plus y into phi dash of x minus y into partial derivative of x with respect to y is 0 minus partial derivative of y with respect to y is 1 minus of f of x plus y into phi double dash of x minus y into partial derivative of x with respect to y is 0, partial derivative of y with respect to y is 1 plus phi dash of x minus y into f dash of x plus y into partial derivative of x with respect to y is 0 plus partial derivative of y with respect to y is 1. Okay. Right now this gives us t equal to 0 plus 1, 1, 1 into f double dash, f double dash into phi, f double dash, right? Phi, f double dash. 0 minus 1, minus 1, right? Minus phi dash, you'll get minus 1 into phi dash is minus phi dash into f dash is minus f dash phi dash, plus into minus, minus, you'll get minus f dash phi dash. minus of 0 minus 1 minus 1 minus 1 into f phi double dash is phi minus phi double dash minus phi double dash into f is f minus f phi double dash. You'll get minus f phi double dash plus 0 plus 1 1 into f double dash, sorry, 1 into f dash is f dash into phi dash is phi dash f dash. You'll get phi dash f dash. Right, this gives us t equal to phi of x minus y f double dash of x plus y minus f dash of x plus y into phi dash of x minus y minus into minus plus f of x plus y phi double dash of x minus y minus into plus minus phi dash f dash. See, you have two like terms, right? This gives us t equal to phi f double dash minus f dash phi dash minus f dash phi dash gives 2 f dash phi dash, and the remaining term plus f phi dash, f phi double dash. Consider as equation number, say, 5. So this is a different kind of problem. Okay, just find the equation involving s also. Okay, it's not necessary, but please find s also. Fine. Now observe r and t. Here you have f dash phi double dash plus 2 phi dash f dash minus 2 phi dash f dash. Right, here you're having plus 2 phi dash f dash, here you're having minus 2 f dash phi dash, you're having phi f dash f double dash, phi f double dash. Right, here in both the equations you have just 1 2. These two are similar in both the equations, but here you're having plus 2 phi dash f dash and here you're having minus 2 phi dash f dash. Right, so if we try r minus t, if you try r minus t, this term and this term gets cancelled, and you will get minus, okay, plus, you'll get plus 4 f dash phi dash. Okay, so from that you can use the value of f dash phi dash equal to r minus t by 4 if necessary. Okay, fine, let it be. And here if you look at the equation 2 and 3, here you're having f phi dash, phi f dash, phi f dash, f phi dash, the same terms. Right, this remains the same, but here you're having plus f phi dash minus f phi dash. Okay, let's try for, okay, we'll find r minus t first. Okay, now r minus t equal to, that is 4 minus f equal to, see, 4 minus f give, what I'm saying, 4 minus 5 gives r minus t equal to r f of x plus y, I mean f phi double dash plus 2 phi dash f dash plus phi f double dash, okay, minus of phi f double dash minus 2 f dash phi dash plus f phi double dash. Right, I'm just trying to kill this mosquito. Right, stop. Right, this gives us f of x plus y into phi double dash of x minus y plus 2 phi dash of x minus y into f dash of x plus y plus phi of x minus y into f double dash of x plus y minus phi of x minus y f double dash of x plus y minus into minus plus 2f dash of x plus y, phi dash of x minus y, minus into plus minus f of x plus y, phi double dash of x minus y. Right? You can cancel these two, f and phi double dash, and also you can cancel phi f double dash. These two remains. Right? We have two remaining terms. Just add it up. You'll get 4. When 2 phi dash f dash plus 2 phi dash f dash gives 4 phi dash f dash. Now we are having the value of r minus t. Okay, fine. So observe, in P you are having phi of x minus y, I mean phi f dash plus f phi dash, and in Q you are having phi f dash minus f phi dash. A plus B, here you are having A minus B. Okay, if we consider, say, suppose A equal to phi f dash and B equal to f phi dash, you have P equal to A plus B and Q equal to A minus B, isn't it? A minus B. A is nothing but phi f dash. Just assume this, okay? B equal to f phi dash. So if P equal to A plus B and Q equal to A minus B, how about P square minus Q square? What value will get if we find P square minus Q square? Because we are having A plus B, A minus B. If this whole square gives A square plus B square plus 2AB, A square plus B square minus 2AB, right? So P square minus Q square gives A square and B square gets cancelled, and we'll add the remaining terms. And let's see what happens if we do this, okay? Now, P square minus Q square equal to P square. I'll take this as first term and this as second term for my convenience, okay? Because here you're having minus f phi dash. You can take it in the second term here, right? So I'm taking this f phi dash here as second term, okay? Don't get confused. So first term whole square, that is phi f dash whole square, okay, plus second term whole square, that is f phi dash whole square minus 2 times phi f dash f phi dash, 2 times phi f dash f into f phi dash, right? This is into, okay, these two terms into this, right, minus of Q square, A square plus B square. I'll consider it as A and this as B. I'm going to find A minus B whole square here, okay, plus B square, that is f phi dash whole square, minus, because you have minus here, yeah, here you're having A plus B whole square, right? So you'll have plus here. You don't need to write minus, okay? I'm so sorry. I'll remove these brackets also. Fine. Now it's clear. Minus 2AB, 2AB, that is 2 times A phi f dash into f phi dash. Right, now simplify it. Right, now this gives us P square minus Q square equal to phi f dash whole square is phi square f dash square, right? Or can we cancel it directly? Yes, you can cancel it directly. Let's cancel directly, okay? I'm writing the same steps. First 3 terms remains the same. Minus first term minus into plus minus second term minus into minus plus last term. Right. Okay, now we can cancel this out. We'll get, see here in whole square. Okay, 5f dash whole square minus 5f dash whole square gets cancelled. f5 dash whole square minus f5 dash whole square gets cancelled. Plus 2 5 5 dash f dash plus 2 5 5 dash f dash. We'll add these two. We'll get p square minus q square equal to 2 plus 2 4 5 5 dash f dash, or you can write this as f phi, that is f of x plus y into phi of x minus y into phi dash f dash. Okay, so you got phi dash f dash. You got all the terms, right? Fine. Now you got p square minus q square equal to 4 into f phi dash f dash. Okay, good. Now look at the results. Look at the result we got using 4 minus 5. Here 4 phi dash f dash can be replaced by r minus t. 4 phi dash f dash can be replaced by r minus t. So we'll replace 4 phi dash f dash using r minus t, and using equation 1 we'll replace f phi by z. Okay, I'll show you clearly. Now we'll write this as p square minus q square equal to f of x plus y phi of x minus y into 4 into phi dash f dash. Since 4 into phi dash of x minus y into f dash of x plus y equal to r minus t, right, by equation 4 minus 5, right? And also since f of x plus y into phi of x minus y equal to z, right? So we'll replace f into phi by this z. We got this by 1. Okay, z into this can be replaced using r minus t. You'll get r minus t. So this is the required partial differential equation. We know that p is nothing but dou z by dou x. You'll get dou z by dou x whole square minus dou z by dou y whole square equal to z times r is nothing but dou square z by dou x square minus t is nothing but dou square z by dou y square, which is the required partial differential equation, and this completes the problem. Which is the required partial differential equation. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.